All right. Now let us take a look at the body-centered cubic. Body-centered cubic, where we have a cube with one atom in the body, which is in the middle of the cube, and we have 1/8 atom at each of the corresponding corners. So we have in total 2 in one BCC. So as the title mentioned, BCC to FCC reciprocity. So we move to a more interesting relationship. As I mentioned, we expect there are deviations between the structure, the crystal structure in the real space and also in the reciprocal lattice. So the reciprocal lattice of BCC, if in the real space is body-centered cubic, in the reciprocal lattice, it is predicted as FCC, the face-centered cubic. Yang SC tadi simple cubic, dalam real space simple cubic, dalam reciprocal lattice it will also simple cubic. But BCC in real space, it will become FCC in reciprocal lattice. So vice versa, the reciprocal lattice of FCC pula, dia akan jadi BCC. Gitu. The BCC dengan FCC akan interchange to each other. Gitu. So this is a very important result in solid state physics, because it shows us that reciprocal lattice is not just a copy of real space, it reorganizes the symmetry information in a different but systematic way. So please remember the pairing of BCC and FCC. Real space BCC, reciprocal space FCC. If the real space is FCC, the reciprocal space become BCC. Macam tu. Itu je punya perbezaan. Kan? Dekat dia punya side length, dia always 4 pi over A. Itu. Kan? The side length in real space is A, but in reciprocal, the side length is 4 pi over A. Same goes for BCC of FCC ataupun FCC. Maksudnya the length, the side length of the cube. Gitu. So this slide helps us to compare the three main lattice types visually in reciprocal space. For SC, simple cubic, it's very simple. And real space SC, reciprocal space SC, very simple. It is the FBZ. Saya tulis kat bawah tu, FBZ is the first Brillouin zone. So the first Brillouin zone is a cube. This is the simplest case, the dual structure, self-dual structure. FBZ is a cube centered at gamma. So remember, I will ask you, the first one is K. What is K? Second one is what is gamma? Nampak yang macam L terbalik tu kan? That is gamma. Yang ni. Ini. This is gamma. Saya akan tanya randomly lah. Nasib lah siapa saya akan tanya tu. K, what is K? What is gamma? Saya akan tanya. Okay, now. For BCC and FCC, the Brillouin zone shapes are different because the reciprocal lattice changes. Use this slide as a visual memory aid. SC remains SC. BCC and FCC transform into each other. The BCC becomes FCC. The FCC becomes BCC. Do not just memorize words. Look at the symmetry and geometry. Pak ni. Nanti you akan tanya lah, so Pak ni bukan kata cube ke BCC? Ni bukan cube. Ini dah pentagon. Bukan pentagon. Ni apa? Rhombic dodecahedron. A structure where each faces are actually pentagon. Right? Pentagon, we glue them together, becomes rhombic dodecahedrons. This is the first Brillouin zone shape. Okay, it is in real space BCC. In the reciprocal lattice is FCC. Okay, now the Brillouin zone can be constructed. The one that we learned just now, we are constructing in 2 dimensions. That's why we could draw very easy the first Brillouin zone. But in real environment, we are not dealing with 2-dimensional. We are dealing with 3-dimensional. To draw the three-dimensional structure is very, very RAM draining. If we use our own brain, we cannot solve three-dimensionally. That is why we need software. Kita ada software khas dia. And from the software, I mean, I have a software over here. The name of the software is Shape V7.4. Unfortunately, I cannot give you this software because the license of the software only being licensed to me alone. But I could show you the software later in the class or any time, any free time. Okay, so based on that software, we could draw the first Brillouin zone of the BCC. Okay, sorry, of the FCC. Salah, bukan BCC. Kita draw weakness side cell. In reciprocal lattice, the FCC, we draw the first Brillouin zone. So this is how the first Brillouin zone of an FCC looks like. The shape is in a rhombic dodecahedron because it's three-dimensional system. We don't draw the weakness sides and also the first Brillouin zone using our hand. No, we never do that. What I show you just now, that is only for basic educational purposes. How it should be drawn. So the software letter will draw three-dimensionally, but just following the same exact procedure. Pick an origin, draw a dash line with the origin connected to the nearest neighbor, then draw the bisector, and the area encapsulated by the bisector will become your first Brillouin zone. That is two-dimensional. But in 3D, it's much complicated. We cannot draw them because we don't have paper with three-dimensional. The paper is in two-dimensional. So that's why we need software. And the software shows us that for an simple cubic, in the reciprocal space, the shape of the first Brillouin zone is still a simple cubic. But for a BCC in reciprocal space, it is an FCC. And in three-dimensional system, it's not a BCC, but instead it is a rhombic dodecahedron. And how about for an FCC? FCC in real space, in reciprocal space, it is BCC. And the shape of the first Brillouin zone is the truncated octahedron. That is the face of the truncated octahedron. I could see, I could understand, but I also cannot construct it inside my head. It's very complicated. We need to use the software. If you want to see the software, you could Google first. It's Shape, SHAPE V7.4. Shape, bentuk, shape V7.4. It is very expensive. GMP mampu bagi saya satu lesen je. That's it. But it is very powerful. I could show you later. So what's next? Oh yeah. Now, quick check number two. Let us test your understanding again. Choose the correct statement and be prepared to justify your answer. Do not rely only on your memory. Use the definitions of reciprocal lattice and Brillouin zone that we have just built. Okay, so let's see the question again. Which one of the following statements is correct regarding reciprocal lattices and Brillouin zones? Recall the geometric relationships between direct and reciprocal space. Tengok A. Reciprocal of FCC is FCC. True or not? True good. True good. Kan lah. Kan? Wrong. So the reciprocal BCC of BCC lattice is an FCC lattice and vice versa. Okay. Dah jawapan dah aku ajak betul. Ada jawapan kat sini rupa-rupanya. Stay in the call. So jawapan adalah reciprocal BCC is FCC. First, Brillouin zone is the weakness side cell in real space. First, Brillouin zone is no. Reciprocal lattice vectors have unit of length. No. Where God? Kan? This is the correct one. Right. I think that is all good. To summarize the whole chapter, we move from crystal lattice and unit cells to diffraction and Bragg's law, then to Fourier interpretation and reciprocal lattice, and finally to Bragg planes and Brillouin zones. So the bigger picture is this: the reciprocal lattice gives us a more natural way to understand diffraction and wave behavior in crystals. So this chapter is actually really about connecting structure, periodicity, and wave physics. Itu sahaja, kan? And I could not really teach you the solid state physics now, because previously we are really teaching students the solid state physics based on the standard solid state physics for physicists and material physics. But since you guys are not really the core or the pure physicists and the pure material physicists, you guys are material technologists, we only take the application side of solid state physics. So, but if you still hunger for more information about this material physics or mathematical physics, you should start with the Kittel, Hook, and Hall and Omar. That will be the main textbook for material physicists. Charles Kittel. Rasanya there the free version online. I don't know. You can check. I think in library we have that book. Yeah, definitely we have that book in our library. So for additional reading and visual explanations, the online references are also useful. I strongly recommend you to visit the sections on reciprocal lattice and Brillouin zones, because they are essential for later topics such as phonons and band structure. Also, I did not include in these slides the 14 arrangement of crystals and 7 crystal structures, which I will ask you how they look like. You may use your AI, you may use your ChatGPT or GenSpark or whatever AI that you have, or Gemini. Okay, but I want to know. I will ask. First, I will ask K. Second, I will ask about gamma, and the third one I will ask about the 14 crystal arrangement, and number 4 I will ask what are the 7 type of crystal categories. All right, I think that is all, guys, for today. So looking forward to attend your assignment explanation on Friday. So I wish you all the best and good luck. That is all. Thank you very much. Class dismissed.